Hey everyone, and welcome to this explainer. If you've been relying on traditional firewall rules and wondering why threats are still somehow slipping through the cracks, well, you are definitely in the right place today. We're going to break down the fundamental concepts of Palo Alto's App ID and show you exactly how to migrate your network to a much more modern, robust security posture. Basically, we're exploring how to drastically shrink your attack surface by completely changing the very foundation of how you identify network traffic.
All right, let's take a quick look at the agenda. We've got 5 key areas to cover. First, the flaw in port rules. Second, understanding App ID. Third, visibility and control. Fourth, filters and tags. And finally, the exact migration path. It's a lot of ground, but by the end, you'll know exactly how to implement a significantly more secure framework. Let's dive in.
Section 1. The flaw in port rules. We really need to look at why legacy firewalls are just failing us. To appreciate the solution, we have to understand exactly why the old way is broken.
So, are your port-based rules actually secure? I mean, you might think you're safe because you're monitoring default ports like TCP/80 and TCP/443, right? But here's the reality. Developers now use these as generic transport protocols. This allows countless evasive applications to fly completely under the radar. Back in the day, port-based rules worked like a charm. FTP used port 20 and 21, Telnet used 23, and that was the whole shebang. But today, using ports 80 and 443 is literally just the fastest way for developers to get their applications deployed. HTTP and HTTPS aren't just single applications anymore. They're the highways that everything else drives on.
Just look at the stark contrast here. Legacy rules assume safety based merely on a port number. It's kind of like a security guard at a club who only checks if you're wearing a blue shirt, and if you are, you're waved right in. Blind trust. Application-based control, on the other hand, actively interrogates the traffic to expose its true identity. It checks your ID, your background, and your intentions before ever letting you through the door.
Moving on to Section 2, Understanding App ID. This is where we talk about the positive enforcement model and really the hero technology of this whole explainer.
Okay, so what actually is App ID? The crucial takeaway here is that the very second traffic hits the firewall, App ID springs into action. It will even decrypt traffic if it has to. It uses multiple techniques all at once, like application signatures, protocol decoding, and heuristics to identify the exact application before making any security decisions whatsoever. It simply doesn't matter if the app hops to a non-standard port or tries to hide as legitimate encrypted traffic. App ID is going to figure out exactly what it is.
This quote really hits the nail on the head. It perfectly illustrates this massive shift in our security mindset. Instead of playing whack-a-mole and endlessly trying to block the unknown bad, you lock down your attack surface by explicitly allowing only the applications your business actually needs. This is the positive enforcement model. Think about it. There are just way fewer avenues of attack when you drastically limit the permitted services on your network to only the ones you've proactively said yes to.
All right, Section 3, Visibility and Control. Now that we've got the engine figured out, let's look at how we navigate actual application usage on the network.
Let's imagine a user. We'll call him Joe. Joe's just going about his workday. We can break down his traffic into 3 distinct categories. First, we have sanctioned apps. These are totally safe corporate tools like Workday. Your business relies on them, so we safely enable them. At the other extreme, we have unsanctioned apps. These have absolutely no business reason to be there, especially if they're known malware vectors, so we just flat out block them. But that middle row, tolerated apps, that's the messy gray area network admins wrestle with every single day.
And for those tolerated apps, we need granular controls. For instance, we might let Joe download a vendor document from Dropbox, but we are absolutely going to block him from uploading sensitive company data there. You see, App ID doesn't just see the application, it sees the distinct functions happening within that application. You can allow screen sharing, but block remote control. You can allow access to enterprise SaaS accounts, but completely deny the free personal versions of those exact same platforms. It's incredibly precise.
Now, to keep track of all this without losing your mind, administrators rely on the Application Command Center, or ACC. As everything moves to the cloud, it's super easy for network teams to just lose visibility. But the ACC gives you this highly interactive, graphical view to drill down into SaaS usage. You can jump from high-level overviews straight down into individual log entries to spot data risks way before they become actual breaches.
And fueling all of this intelligence is Applopedia. Think of it as a massive encyclopedia for network traffic. If Joe suddenly starts using some brand new app and you have no idea what it is, you don't need to spend hours Googling it. You just punch it into Applopedia. It shows you the characteristics, its history of data breaches, and any underlying dependencies it might have.
It's a real game changer for investigating compliance. Let's jump to Section 4, filters and tags, because managing these rules shouldn't be a tedious manual nightmare, right? Let's talk automation.
So the secret to managing this at scale is dynamic automation. By using dynamic tags, your firewall seamlessly updates its own rules every time Palo Alto releases new App ID signatures. It saves you hours. Let's say you set up a filter with the tag Enterprise VoIP. If a brand new business video conferencing app drops tomorrow and it gets tagged as Enterprise VoIP in the dynamic update, boom, your firewall automatically allows it. You are secure, your rules stay elegant, and you're completely future-proofed.
All right, Section 5, the migration path. This is the most actionable part of our explainer. Moving from ports to an application-based rule base sounds like a massive headache, but there's a very clear, logical path forward.
You don't have to guess how to do this. You use the Policy Optimizer tool. It's specifically designed to hunt down over-provisioned, dangerous legacy rules and narrow them down to exactly what your network actually needs. If you have old rules that are way too broad, you're essentially leaving the front door wide open for malicious traffic. The Policy Optimizer shows you the actual usage data, exactly which applications are currently riding on those old port rules, so you can convert them safely.
Sticking strictly to these 3 phases is absolutely crucial. In Phase 1, you identify and prioritize. Remember, a gradual conversion is always safer than trying to flip the switch on an entire rule base at once. In Phase 2, you clone and place the new application-based rules directly above the old port rule. This forces the firewall to match the specific application first. Then, Phase 3, review and remove. You check the stats, and if no legitimate traffic has hit that old legacy port rule in a while, it is finally time to safely delete it.
So, as we wrap up this explainer, I really want you to take a hard look at your own firewall rule base. Is it time to stop blindly trusting the port and start actively verifying the application? We've seen how legacy rules fail us, how App ID flips the script with a positive enforcement model, and how the Policy Optimizer gives you a totally straightforward migration path. So I'll leave you with this. What unknown, evasive applications are traversing your network right now, just hiding in plain sight behind a trusted port?